At the dawn of the 20th century, physicists thought they had finished their work. Time was universal, space was fixed, and energy flowed smoothly. Nature followed clear mechanical laws, and every bridge, engine and factory depended on them. But within 10 years, every one of them would fail. The first decade of the 20th century is when they discovered that physics was broken. Around the turn of the 20th century, physicists were trying to explain something simple. Why hot objects glow. Heat a piece of metal and it turns red, then orange, then almost white. Blacksmiths knew it, engineers knew it. What no one expected was that the glow would hit a limit. The math said that it should get brighter and brighter forever. But it didn't. The rules known at the time were broken. In December 1900, Max Planck proposed a fix. Energy, he said, is emitted in discrete packets. He introduced his idea almost reluctantly, just to make his equations match reality. Planck didn't think he was launching a revolution, he was just trying to make the math behave. But what it meant was that energy had a smallest unit. If Planck was right, then your universe was not smooth. Energy was not continuous. Nature, at its most fundamental level, was granular. This should have shattered physics, but instead, quantum mechanics was born. Within a few decades, those tiny packets would explain atomic structure, chemistry, semiconductors, and eventually power every transistor, laser, and microchip on Earth. The universe, it turned out, wasn't analog, it was digital. The first crack appeared in heat and light, but it didn't stop there. When scientists looked closer at light itself, they discovered that the problem wasn't energy, it was time. For centuries, everyone agreed on one thing, that time was universal. A second in London was the same as a second in Paris, or anywhere else in the universe. So since everyone was agreed on that point, scientists tried to measure it. Since Aristotle, physicists had assumed that light travels through a gel-like substance they called ether. After all, sound doesn't travel through a vacuum, so how can light pass through empty space? In 1886, to measure how much ether slowed light, two American physicists, Albert Michelson and Edward Morley, bounced beams at perpendicular angles. The beam going against ether's current should slow it, just as water slows a swimmer crossing a river. After testing and testing, Michelson and Morley found that light never slowed down. Ether, they suggested, did not exist. No matter how fast you moved, light always travelled at the same speed. In 1905, Michelson and Morley's ether experiment set a young patent clerk named Albert Einstein to thinking about light as a constant. If light speed never changed, then something else had to. And the only thing that could be was time. Move faster and your clock runs slower. This is not an illusion or a perception, it actually moves slower. Two people moving at different speeds don't agree on what now means. Events that you think happen at the same moment don't for someone else. Time was flexible, and it was woven together with space. The universe wasn't a ticking clock anymore, it was something alive, stretching and bending depending on how you moved through it. If time and space weren't on solid ground, then what about matter? To find out, scientists went looking inside the atom. For centuries, atoms were imagined as tiny solid balls, the final building blocks of everything. Break matter apart enough and eventually you would reach something that could not be divided. But experiments in the early 1900s told a very different story. When scientists looked closely, they found that atoms weren't solid at all. In fact, they were almost completely empty. A tiny, dense center surrounded by activity. Almost all of mass packed into a point so small it was nearly impossible to imagine. Everything else? Space. Which led to a strange realization. The hardness of the world, tables, walls, Even your own body isn't solid matter pressing together. It's forces pushing back. Electrons in one atom resisting electrons in another. The world only feels solid. Underneath, it's almost entirely empty. Matter wasn't the simple substance that scientists once imagined. It was a structure, and like time and energy, it followed rules no one else could see. Now that physicists had taken matter apart, one force still remained firmly in place: gravity. All of these other discoveries had shared something in common. They were invisible. Energy came in packets no one could see. Time itself could stretch or shrink depending on how you moved. The forces inside atoms that were mostly empty space, could only be detected through very careful experiments. Most people never noticed any of it. Flight was different. You could point to it. You could immediately see its usefulness. In December 1903, on a windy beach in North Carolina, a fragile wooden machine lifted itself off the ground. Not by accident or a lucky gust of wind, but because two bicycle mechanics from Ohio had figured out the problem. Most earlier attempts at flight had failed for one simple reason: they couldn't steer. Wilbur and Orville Wright could. They built a system that allowed the pilot to remain stable in the air, correcting the machine moment by moment. For the first time in history, humans weren't just flying, they had learned how to overcome one of the oldest laws in nature: gravity. Not by defeating it, but by mastering the forces that could counter it. Lift, thrust, balance. They were flying on purpose, and once that happened, the implications were obvious. Distance that once took days would soon take hours, and the world itself was about to become a whole lot smaller. To most people, nothing had changed. The streets looked the same, clocks ticked normally, and life moved forward. But underneath, energy came in packets, time stretched and shrank, matter dissolved into force fields, and humans had left the ground. The rules had already gone. Society just hadn't noticed yet. By the end of the first decade, reality had shifted, and the next one would force humanity to live by the consequences. Thanks for watching. At the turn of the century, scientists thought they knew just about everything. Turns out, they were just getting started. If you like this content, please like, comment and share. It really helps the channel. Stay curious, and I'll see you in the next episode of How the World Was Changed.